repeating myself. Today I'm going to take an exam, which is a mock exam. And these are the questions. Please write down the questions, and these there will be two questions. One is write down the VHDL code for full adder, show the hardware simulation of 8-bit parallel adder taking in the correct IC. First of all, you need to do this, then you have to submit in a Google form, which the link will be given after the exam is completed, the time is completed, and it will take inputs only for 10 to 15 minutes. You have to be very careful. Once I give the link in the chat box, after 15 minutes, it will not take any responses. And one more thing, you have to follow these instructions. Please take a picture or write down whatever it may be. Those who are late, just take a picture. Inputs will be 0 1 1 0 1 1 0 0 for A, from A1 to A8. For B1 to B8 will be 1 1 1 1 0 0 0 1, and output will be calculated by you for hardware simulation. Make a doc file and PDF file which will contain your name, roll number, enrollment number, and section, and submit this after 1 hour when I tell you to submit. And one more thing, the what will be submitted in the PDF file, that is also written here. Please read the instructions carefully. Hope you can see it, and please write down it. And one more thing, if you want to ask me just 2 to 3 minutes more, just ask me right away. Otherwise, I'll not be available, and I'll be silent. I'll be on silent mode. I'll be there, and Viva will take place after the assignments have been submitted or assignments are done. Well, once you are done, just let me know, ma'am, I am done with my assignments. Then I'll take your Viva, 2 to 3 questions per head. This is how the mock exam is happening, and this is a small version of your original exam. And the Viva will be depending on the, solely on the assignments today. So now I'll be starting the exam. So I'm stopping my screen share right now. Ma'am, some of us didn't have laptop with us. Can it be done? Okay, those who don't have laptops, then please give me a Viva. What else I can help? I don't know, Ayush, because really I don't have any idea. If you guys don't have any laptop or something, how can you give exam online? I don't have any idea. I will suggest you guys to talk to HOD sir so that he can help you about this problem. Okay, just start your exam. Those who have laptops or whatever, PC, whatever, start your exam. I'm just writing here, start your exam, and your time starts now. 2:31 it is, and I'll be giving the submission link on 3:32. 3:32, and then it will be open for only 15 minutes. I'll be waiting for 15 minutes only. And one more thing, once you're done, just let me know. I'll take the Viva. Okay? Just go ahead. Hope you guys have understood the questions. Go ahead. All the best. If you are having any problem, please ask me right away. I'm here only. And please don't leave the meeting. You guys have only, requested to VC sir, Pro VC sir, that we should give you a mock lab exam. And that's why we have arranged this one. Please, I am requesting you to submit the assignments. Yes, Subramanian?
No.
I guess there's no questions. Once you're done, please let me know. I'll be starting the vivas. Okay? Please let me know. Shambhashev, you are late. Exams are going on. See, the instructions are given in the chat box. You have been late, still I permitted that. That's why, because this is an exam. So please read the instruction is the in the chat box given. It's given everything. Everybody is busy with giving exam. Those who have joined later, please read the chat box, read the instructions for exam. Mock exam is going on. This is how your lab exam will be conducted, original lab exam. This is a demo mock examination.
Hello, ma'am. Good afternoon.
Yeah, good afternoon.
Ma'am, can you again share the instructions as there is no instructions
Okay,
visible to me in the chat box?
okay. Wait,
Thank you, ma'am.
wait. Three 330 is the limit. 335. Within that, you have to complete the you know two assignments which are given in the chat box, and whoever came later, please follow the instructions. I don't know why other ones didn't ask me about the instructions. Anyway, just do it in your laptop, and everything is written, I guess, and it is visible. All the best. At 3:35, I'll be giving you the link of the submission. Along with that, I'll be taking your Viva exam. Okay, 2 to 3 questions per head. Please be prepared. The Viva will be solely nonsense. Don't panic. If there is anything you want to ask me about the examination, original examination, you can ask me also. I'm available right here.
Hello, ma'am.
Yeah, tell me. Tell me, Raviraj, what happened? What's your problem? Sorry, I can't hear you. You can write in the chat box as well.
Good afternoon, everyone. Medhasri ma'am still here?
Yeah, I can hear you, Shuchira ma'am.
They are taking the exam, right?
Yeah, they're giving the exam, and many of them has joined later.
Okay.
That's why I have given the information twice in the chat box. Till now, join requests are coming. I'm not accepting it anymore, and it's already been 3:03, and the class was from 2 p.m.
I
And I have
accepted.
given them.
I
Yeah,
accepted
tell
two
me.
of them anyway. I accepted two of them. What I
Okay.
say, okay, let them in, and just uh, let them try. We still have 1 hour, right?
I'm just okay. If any next one is coming, I'm just letting them in. Till now, I have let them in.
Okay.
One more thing, Suchita ma'am, when would the Viva will start? Please tell them.
From where?
Viva
Right.
about the
We need to make two PDF,
no, one PDF form.
one PDF.
In one PDF or doc file, you need to,
Ma'am, please
collab
send
all
the
this.
link again.
Yeah, Raviraj, tell me. Sorry, I can't hear you, Raviraj. You have muted
Ma'am,
yourself.
ma'am, please send the link again.
Which link? Only okay. Yeah, you are asking for the questions, right? I'm giving you the questions once more in the chat box along with the instructions. I have given it, and please talk to your friends about the assignments and all. They have known already. Okay, I'm muting myself, Krishna madam. If they ask
Okay.
anything, you please respond. Thank you.
Sure. So you have any problems or queries with whatever has done till now, all the lab experiments? If you have any problems from the experiments, you can tell me now, like from assignment 7. Well, living from what you're doing, of course, in subtractor circuit or adder subtractor circuit, or is it clear completely? this respond, I asked you something, right? Like if you had any problem or queries or not. Otherwise, I have to assume that you know everything. You have no problem. Are you able to do the experiments or facing some problem? This is just
ম্যাম
yes.
ম্যাম 8 বিট প্যারাল অ্যাডারটা তো দুটো 4 বিট প্যারাল অ্যাডার দিয়ে বানাবো
8 বিট দিয়েছে না
হুম।
হ্যাঁ দুটো 4 বিট দিয়ে বানাতে হবে 8 বিট বানাতে হবে কাস্কেডিং করে you have to cascade two 4-bit parallel adders to make an 8-bit parallel adder. Okay, do you remember how to do that?
ম্যাম
Hello, ma'am.
Yes.
Ma'am, in the 8-bit parallel adder, there is a input that is A and B. So, how
Yes.
can I put the input? Can you please help?
Yes, I'll show you. Whatever confusion you have to clear it right now, today. Okay. And this mock exam, this is just to give you some flavor, like what kind of question is going to come in the term 1 exam. Okay. So this is for your convenience only. Okay. So I think you have this problem with cascading. So
Ma'am, I am doing the just how can I put the input? That is the problem. Actually, cascading part is done.
mhm.
4-bit.
Your
In each 4-bit parallel ladder, there is a A4, A3, A2, A1. So,
Yeah.
actually, how can I put the 8-bit number to 4-bit parallel ladders? That is my problem.
problem, right? So you see you have got two 8-bit adders, right? So in each of the adder there are like 8 A bits, right? Say you have got, I'm writing in the chat box, okay? So you have got adder 1, say label D1, say U1 is first adder, say U1 is first adder and U2 is second adder. Then you have to consider from U1, sorry, from the second adder, okay, from U2, the 4 bits will be counted as the higher order bits, okay, like A8, A7, A6, A5, like that. And let me write from U2, A4, A3, A2, A1 to be treated as higher order 4 bits of A. That is A8, 7, 6, 5, like this. And from U1, that is the first adder, we have got again 4 bits, right? A4, A3, A2, A1. Those 4 bits to be treated as the lower order 4 bits. That is A4, 3, 2, and 1. Okay, so you got 8 bits. So 4 higher order bits are in your second IC, second adder IC, and the first, that is lower order 4 bits, are in your first IC. Okay, U1. So you got 8 bits. If you just have to write 8 bits, how do you write? You start from 8, right? 8 is the MSB. 8 is the most significant bit. And A1 is the LSB, least significant bit. Understood? In the same way, you have to treat B as well. You got 8 bits or not? You understood or not? Still some confusion.
Excuse me, ma'am.
Yes?
Ma'am, in the question it is given that A equal to 0, 110, 1100. So you wrote in the chat box that A8 will be MSB. So then 0, 110. So that 0 will be A1 or A8.
Okay. You know MSB most significant bit is reading from your right hand side. Sorry,
Right hand.
reading from your left hand side. Then you read towards right, right? Like 0, 1, 1, 0, 1, 1, 0, 0. If you're reading like this, then the 0 is MSB. The first 0 you uttered, that is MSB. And the last 0, where I left the number finished, that is LSB. Right? So A8 is going to be, say I'm writing in the chat box. A8 is going to be 0, then A7 is going to be 1. So I'm reading from left to right. Okay, so that is how it is considered. If you can understand now. This is for 0. Okay, I did not label everyone, each bit. Did not label each bit. I labeled up to A6 and gave A1. Okay. So you need to understand, you know this bit weightages, right? Like how we weightage, the 0th position is 1, and then like how you convert this number, this binary number to decimal. Okay. This is your 16 in decimal, right? The 16 in decimal, right? 1000. And why so? Because of the weightage. You have the maximum weightage as 16, right? 2 to the power 4. Am I right or wrong? I think I missed 1 0. Sorry. 1. Okay, ignore that. I missed 1 0. Zero, 1. Plus 0. No, that was correct only, sorry.
And then the Google form will be open at 4 p.m. or 3:35.
You do now. I'm there. You submit.
Okay.
There is no time pressure. You submit by 4.
Okay.
Okay. That was correct. Sorry. So, what I was trying to say, you've got this position as 16 weightage. So that is your most significant bit. That is the 16th position of 16th weightage. That is your most significant bit. So from where you are reading? From left side, like 1000, like that. Are you getting me? So that is your MSB. And the least significant bit is the bit with least weightage. That is 2 to the power 0. That is 1. Okay? Are you getting me? So I hope this is clear. If it is not clear, then please like speak out.
Suchina ma'am, I would like to ask one question.
Yes.
Ma'am, I have given the link in the chat box of submission link. Okay.
Yes.
So when they are done, we can start taking Viva once they are done.
Viva. Okay, I'll take in between itself. Okay, because I have told them they are slow. They have some
Okay.
problem understanding. So I have told them to take the full time, and I'll take Viva in between. No problem. Okay. Okay. Yeah.
Fine, ma'am.
So, what I explained about MSB and LSB, right? So is that clear, or I confused you even more? Respond. Otherwise, it's very difficult to understand.
Confused.
You're more confused? Okay. So can anyone respond? Like, you can read this number 1001. Which position is MSB and which position is LSB? You know that, right? Okay. Let me see. You know the positional values? See, I'm presenting my screen, okay? Have a look. Okay, here. You can see my screen. Yes?
Yes, ma'am.
Yeah. So let's just take, I'll take one 4-bit number. Okay, you have to understand it for 8-bit number. Okay. So let's have this. I'm writing like A. Okay, A for a binary number. What I explained to you at first, I started from 1. That is just a label. So you may start from 1 or you may start from 0. If I just, this is what I had told you. Say 4321 are 4 pins of an IC. These are like 4 bits. But when we consider bit positions, we don't count from 1 basically. We count from 0. Okay, let's have a binary number. Say 1, 0, 0, 1. This is what I had given. Okay, so what I count from? I count from bit position 0 basically. So I'll write like this. So this is a binary number, so each bit position will have some weightage. So the first bit position is counted as 0 and it will have the weightage as 2 to the power 0, that is 1. Second bit position is counted as 1, so it will have weightage as 2 to the power 1, that is 2. Third bit position will have weightage to the power 3, okay, that is 8. And the fourth bit position will have weightage to the power 4, that is 16. Okay. So if I ask you which bit position has the maximum weightage, what did you respond? the bit position that has the maximum weightage, we call it most significant bit. Okay, that we call it MSB. And when giving input to an IC, we would consider this A4 as MSB. So if this is, say, an IC pin input or output, whatever.
Ma'am, is it the 8421 system?
Yes, so it is like, see, what you are saying 8421, I think you are referring to this binary coding system, right? So,
Yes.
yeah, but it is the same concept basically. What I am giving you example is simple binary to decimal conversion. That indeed follows the 8421 system, but not necessarily that it will always have this maximum value as 8, I mean bit position value as 8. So here you can see the maximum bit position value is also 16. It can be, if I increase another number, say like this, then what is the MSB? MSB is the fifth position, that is to the power 5. In that case, this becomes the MSB, the one I have selected. That has the maximum. This bit position has the maximum weightage. So you think about the weightage, positional weight. For any number system, actually this is valid. You can get an easy analogy with decimal system also. For 0 in a decimal system, what we understand? 0 is 0, right? Then if I give, say, 10, it means 10, but that means 10 to the power 1 also. You see. And if I mean 100, it means 10 square also. So I'm just trying to give analogy with these two systems. Don't confuse. What I mean is this one, when shifting towards your left, we are having higher positional value. If 1 is at the second position, we have 10 to the power 1. If 1 is at the third position, then it is 10 square, 10 to the power 2. If it is even like this, it will become 10 to the power 3. So now I hope you understand that which bit or which digit, whatever you call, I should understand as MSB, most significant bit position. That should always come from your, if it is left and this is right, that should always become your leftmost bit. This is your basically leftmost bit position, always. This is true for any number system, not only binary or decimal. It is true for octal as well as hexadecimal or any other number system what you can imagine. Are you getting my point? So whenever I am saying that in an IC pin input or say output, whatever it is, if I am saying that A4 is the MSB or most significant bit position, then how you should input the number? You should start from left. Okay? You should start from left, like we naturally read any number. Like we naturally read, right? 11001. This is reading from left to right. In that order, you will give the input. From, say, if it is 5-bit, from A5 to A1, you will, in that order, you will put the input. So if it is an 8-bit number, what will happen? So A8 is the MSB in that case. So this, get the analogy. So if an IC pin input is to be given from A8 to A1 and it is mentioned that A8 has to be treated as the MSB, or you're say, assuming that this A4, this A8 pin is MSB, you're putting like that. So in that case, in which order you're going to give input? You'll naturally read out a number like this, 11001, and in the same order you'll put the input. Like from A5, it will come as 11001. Simple. It's very simple basically. Understood? So whenever I'm cascading two IC, what happens? We have two groups. This one group of pins, say 4, 3, 2, 1. So one group of pins are available in one IC, another group is available in another IC. So how we are going to put? This will be your second IC and this is going to be your first IC. Okay? And how we cascade? When I say first IC and second IC, you have to make sure the cascading also follows that. Cascading would be like U1 ICs see out. That is the first ICs carry output should go inside. The second ICs carry input. Understood? Why? Because the addition would happen from where? The lowest bit position side, right? That is how we naturally add. Like we start from here, from the right side. This is the lowest bit position. So say two numbers we have. So we are adding and we are forwarding the carry to the next higher position. So if I am considering U1 as the lowest, lower bit positions like A4321, lower bit positions of the 8-bit number, then whatever carry we get from 4th bit position from here, it should go to the next IC's Cin. Okay? It should go here. Is this clear? I need to basically save it. So this Cin of the second IC U2 is coming from the C out carry output of the most significant bit position addition in U1. Okay, that goes to here. So that is how the cascading is being done. Here I'm writing the mapping. Don't confuse. Now I'm writing the mapping with the 8-bit number. Okay, this is the mapping. The second line I have written, that is the mapping with your 8-bit number. And this is how the IC pins should be. Yes. Tell me.
Then what will be given to the scene of the first IC?
Come again. I didn't get you. Come again, please.
Then what will be given in the what will the value will be given in the scene of the first IC?
What are the values that will be given to the first IC, right? So you should try.
Scene of the first IC.
Yeah, understood. Cin of the first IC, you are performing an addition, right? So whenever we perform an addition, Cin means what? Carry input, right? So carry input comes Cin actually, this P means the carry input at the lowest bit position. Here, you can see right here at the lowest bit position at the LSB side. So for an addition like operation, do we have a scene at all here? We do not have any other ICs here or any other bit positions here, right? So from where this scene will come? So this scene would definitely be 0. Okay? For addition, the scene at the lowest bit position for the first IC would be 0 always. You understood why? Because we do not have any carry that is propagated from any other stages. We do not want to give any carry input here. We are just starting out the addition, right? So we definitely do not have a carry here. Carry when it gets produced. Carry gets produced when we add two bits in a particular position, and if we have say some 1 1 kind of, so 1 plus 1 would give us 1 0. Then out of that 0 would be your sum and 1 would be carry. So one extra bit position that is getting generated, that is carry, and that will be forwarded to the next bit position for addition, right? So in the lowest bit position we do not have such carry input. Is that correct?
Yes.
Are you convinced? I mean, if you are not convinced, keep on asking questions. It's very important that you get convinced with the explanation I'm giving, or at least you try your explanation or your summarization. You should be very much, comfortable with this concept.
Ma'am, can you please explain subtraction or using OR gate?
Yes.
Like the circuit is giving error when performing 2TS.
Yeah. This is the circuit. Okay. This is basically your adder subtractor combo unit. Okay. In single circuit, you can perform both addition and subtraction. Adder subtractor unit, like that we said. Okay. So now you see, I'm giving you the explanation. You understood the addition, right? This is for any adder circuit you see. For any adder circuit, so when we add two numbers, say A and B, definitely the carry input, as I explained, is going to be 0. And B also is as it is, and A also goes as it is. These two are say positive numbers, and we'll get the carry output and 4-bit sum. Okay, that is how an addition is done. But when we are performing subtraction, it can be thought like A plus minus B. It can be thought like A plus minus B. Now, how can I represent this negative number? We are going to represent 2's complement. Okay, 2's complement form to represent a negative number. We will be using 2's complement form. And as you know, how we find a 2's complement? We find it by 1's complement. 1's complement is simply complementing the bits. Like 0 to 1, then 1 to 0. Simple. As simple as that. So we get a 1's complement form, and with that I add a 1. If I do that, I get the 2's complement form of that particular binary number. So that's how it is done. Okay. So I have to now convert this minus b, so whatever form it is, signed or whatever it is, to this 2's complement form. So for that, what I need to do, you take the positive value of b. Okay, we have to give that as input and bitwise XOR it with 1. Now I explained you in the last class why XOR helps. That is because if you see the XOR's truth table, 1, say 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0. So this is your bitwise XOR's truth table. So just focus on this term also, okay? That I'm saying repeatedly that it has to be bitwise. So it means that, say I have, if this is my b, b's magnitude, then for each bit, for each of the bit positions, say 1, 0, 0, 1, 1, for each of these bit positions, we need one XOR gate and we need to perform a XOR operation. So that is when we call it is a bitwise XOR. Bitwise XOR. For each bit we perform a XOR operation. So you see, if these are two bit positions, say these two bit positions means XOR's first input and second input. XOR takes two inputs, right? It is like it's not unary operation, it's binary operation. So it takes two inputs, like this pin 1 and pin 2. So in that case, if you see, when we get a complement of, say I'm writing in small, these are basically two pins of XOR. So when this value, say A, gets complemented in the result, means after XOR, it happens whenever the other input of the XOR is 1. That means if I apply B as 1, A XOR B would be A XOR B would be 1. Right? That means A got complemented here. So A got complemented here. Whereas similarly you can see here A is 1 and B is also 1, means the second input is also 1. Then again we get a complement of what I applied to the first pin of XOR. So like that. So we can basically complement a bit by XORing it with 1. Right? On the other hand, if I give B as 0, if I keep the other XOR input as 0, the value of A would not get complemented. It will come as it is. So it will come as A only. So this is important. Okay, now let's I just wrote in another notepad. You can see this. This is the explanation, say for subtractor, okay? So what I said that A plus 2's complement of B, in that way we perform a subtraction. And 2's complement can be found as 1 complement of B, that is simply the complement of each of the bits and adding a 1 to it. So you can easily now get each of complemented bits for B by bitwise XOR that I explained. You can see in the circuit that if I apply the B bits here in say line 2 or 5 or 10 or 13, so these are going as the bit value for B. Then if I apply on the other pin 1, you can see the source other pin goes to this high voltage. This is power. If I apply it as 1, what will get as output? From the truth table we saw that we'll get the complement of this value. That is B complement. Okay. Whatever we applied here in 2 or 5 or 10 or 13, those bits will be complemented. So basically, we got this. This is applied as it is in the A pins. We got the B complements here in the B pins. And now we need to add a 1 also, right? We have got to add 1 to get 2's complement. So how can I add that? Now 1 means we know, right, that this is the LSB position, least significant bit position. So we can imagine like this, like we are adding like 0, 0, 0, 1. So we can imagine this 1 as going as the value of C in input. So we basically consider that this 1 is applied as C in input. Because see, in an IC, when I'm using an IC, do I have any other extra input where I can put a 1? I do not have, right? We have limited pins. So I'm going to apply this input somewhere. Otherwise, how can I get the 2's complement? Are you getting me? So we do not have any extra pin so that I can put 1 anywhere else. So only one extra pin that I got is C0. And I'm going to put this 1 here, and C in, as we know, that always adds up as the at the least significant bit position, lowest bit position. So this will complete my task. So we'll get A minus B performed using 2's complement operation, right? And always whenever we perform subtraction in this way, like using 2's complement, then we ignore the carry output from the circuit. We ignore C4. We ignore this C4 that will be reflected in D5 LED. So here you see I have given 1, 1, 1, 1, 15 here, and B input as 0, 0, 1, 1, right? 0, ground, ground, high voltage, 0, 0, 1, 1. That means 3. So 15 minus 3, what should I get? 12. So let's simulate it. You can see these tiny boxes here. You can see, right? So this, if it is red, it means high voltage or 1. Okay, the line is 1 connected to power. If it is blue, means state is 0. The logic state is 0. Okay, that is what it means. And if you just focus on these tiny boxes, you can see that all the XOR gates are basically storing 1 bit of from B, that is applied in the 2nd pin or 5th pin or 10th pin, so on, and another input is always 1. That is because of this line. We call it a control line. Okay, and then you can see this 1 got 0 complemented, 1 became 0 here, 0 becomes 1 here, 0 becomes 1 here. So successfully 1, 0, 0, 1, 1, that is 3, that got complemented as 1, 1, 0, 0, and that is also reflected here in the B pins, 1, 1, 0, 0, and the carry input is also 1, and what output we got is 1, 1, 0, 0, that is 12. 8, this is the 2 to the power 3, right? This position value 2 to the power 3, 8 plus 2 to the power 2, 4, that is 12, plus 0 into 2 to the power 1, that is 0 and 0. So we have in total decimal value as 12 for these 4 bits. So that successfully verifies what we should get from a subtraction like 15 minus 3, right? And we ignore this, as I said, for subtraction. Understood? But if, say, with the same circuit, I have to perform addition as well. Stop the simulation, okay? If I have to addition as well, what I have to do? I have to get whatever P input I apply here in the XOR gets. We should get same output from the XOR, and that should go here in B inputs. So that is obtained by XORing it with 0. This case is covered by XORing it with 0. You see, 1 remains 1, 0 remains 0. Okay. So also for addition we know that C0 has to be 0. There is no case of adding an 1, right? So what do we do? If I just, you see this control line is connected to all the XOR inputs, one of the XOR inputs, as well as the C0. Understood? Now if I make it high for subtraction, it gives us, it makes all these lines 1 simultaneously. But if I just say make it 0, say I'm going to delete it, okay, and put a ground here. Okay. In this way, if I connect it to ground, in this way I make it 0, logic state 0. Then what happens? C0 and all these lines that is connected to this line, that becomes 0. This XOR inputs become 0. Whatever is connected to this line, also C0 becomes 0. However, the other input of the XOR, that is still here 0, 0, 1, 1. Let's simulate and see. Can you see? All these inputs that was previously 1, now it has become blue, that is 0. And the XOR inputs, B inputs are still 0, 0, 1, 1. And see, it has not changed in the output. This 1 is transmitted as 1. This is 1, this is 0, 0. So in the B input also we get 3, 0, 0, 1, 1. And this is 1, 1, 1, 1 is 15, right? So 15 plus 3 is 18, right? So as we are doing addition, we are definitely not going to discard C4 like subtraction we did before. Right? So C4 here you see 1. And which bit position it is? If I count like 0, 1, 2, 3, 4, this is 2 to the power 4, 16. So we get 16 plus, this is 0, plus this is 2 to the power 1. So 16 plus 1, 16 plus 2 is 18. So we definitely got verified. 15 plus 3 is 18, and that is what is our output. I don't know how much I could explain. How much you could understand? It is almost 4. So
Suchana madam, I think they have understood, or otherwise they would have told
I don't know.
us something.
Let them respond. Let them respond.
Yeah.
They should not be so shy. I mean, we are not here to scold
Yeah,
them
they
or
are very shy. Yeah, we won't scold you if you don't understand also.
yeah.
Okay, only one reply is there, understood. Please tell us, other students understood?
Who Who said that yes problem? Vicky Paul. You understood?
Yes, ma'am.
Sure, right? You can perform the experiments yourself.
Ma'am,
Yes.
ma'am, repeat. ma'am, একবার বলো শুনতে পেলাম না।
তা তুমি কি নিজে নিজে করতে পারবে?
হ্যাঁ ম্যাম।
আচ্ছা ঠিক আছে। Then how many of you could submit actually? Response 36 people only. So whatever you have done, okay, just submit the files, whatever, how much you could do, just submit, okay. And this Viva I could not take now, but we'll have extra classes, right? Maybe in the evenings or maybe in the daytime also, maybe on Friday. No, Friday you don't have lab on Friday, but yes, we will get definitely in the evening. So I'm going to ask you from your assignments, I'm going to ask you whatever you asked me today, right? I'm going to ask the same questions. What is MSB, what is LSB, how much, how we are going to give inputs to the IC, okay? I'll check that if you could really explain me even better than me, okay?
Ma'am,
Yes. Yes. Yes, Trey,
given A,
I can't hear you properly.
the subject given A.
Trey, please write it in the chat box. I'm not getting you actually. So write something in a file if you have not done anything. If you could not do anything, you write something in a doc file and upload it because that's a required field. You cannot skip that and give your attendance, okay? Circuit of subtraction using XOR gate is giving error. Okay, if you're getting error or anything, you try yourself a bit more, and if you're still getting some problem, you may reach me in WhatsApp, okay, with your screenshot. Then I'll try to identify what is the problem. Maybe in the doubt clearing class, extra class we have in the evening, we'll discuss all these errors and whatever, okay. But you please try to reflect whatever I have said so far in the previous class, in this class. Try to find out where is the mistake. That is also part of the lesson. Just doing the right thing is not the lesson. I mean, even if you make mistake, you should be able to correct it. Okay, then only it completes. You should never be afraid of making mistakes. Okay, you make a mistake, you correct it. Then only you learn. So try it yourself. Give yourself some time. Take 1 day time. Okay. So I have not taken any Viva or anything today because you have these problems. That is first priority. That's why. So it's already 4 o'clock. It's going to be 4:05. So let's call it a day. Okay. Megashri ma'am, please stop the recording. I think it's done. It's over.
Okay, I'll stop the recording, and I think I should stop